Okay, we're in section 33 of the notes now. And again, it's the continuation of lines. Now they're going to talk about the relationship between two lines that are either parallel or perpendicular. All right, we'll go through this material. Again, it's going to be a short lecture. We're trying to base this on your intuition. There are some exceptions to what we're saying over here, but we'll certainly talk about that when we get to the problem set. All right. Right now, I'm going to go to the share, another share. I'm going to share the actual notes with you and talk through the notes. Just give me a second to do so. Okay. So first thing is, we have two lines now in a plane, and we're going to talk about the relationship between those two lines. And the relationship that we're looking for is the parallel perpendicular relationship. All right. So let's take a look. And give me 1 second and blow this thing up. And we're going to talk about parallel lines first. Now, the objective here is I hope you realize that we're talking about two different lines in a plane. If we look at that, just to point out, they got a line here. And I have another line over here. Now, I'm hoping when you're looking at that, you realize that we're seeing two lines that appear to be parallel. Now, appearances can be deceptive, all right? Appearances can be deceptive. So I'm going to label these lines. And I'm going to call this line 1. And I call the other line line 2. Again, I'm going to look at the slope. When I look at the slope, I want to point out to you, I'm looking at slope as far as being a rise and a run. I'll put this in for you. And I'll do this line first. And this is the rise. And this is the run. All right. Now looking at it, I can say, for the most part, maybe that's not the best triangle to choose. So I'm going to choose a different one. I'm going to choose this one over here. Now someone says, why do you choose one over the other one? It's easier for me to count. Rise. And this will be the run. Now I'm going to get my eraser out. I'm going to erase. This is over here. And this over here. I'm going to erase this triangle too. All right. So let's talk about it. And I'm looking at the rise, and the rise appears to be one solid unit up. What's the run? 2. So line 1, M1 for line 1, well, it's going to be 1 over 2. Well, let's look at the second line. And again, I'm going to draw a triangle in that I can count on. I'm going to say this is the rise. Again, something that's countable. And this is the run. What's the rise? 1. What's the run? 2. So what's the slope for this line 2? Well, M2 is equal to, well, rise is 1 and the run is 2. So what do I notice is, and again, this is a visual. I really do mean it's a visual. I'm not going to guarantee these are the slopes or that they're parallel, but I do want to discuss if the appearance of them, they appear to be parallel, and looking at it, the slopes are equal. So we're hoping, based on your intuition, that if two lines are parallel, right? If these lines are parallel, what do I know? M1 equals M2. Now there is an exception to this. We're not going to worry about that. That'll come when we get to the actual problem set. All right. We'll get to that. All I'm saying right now is we have a very simple test for parallel lines. If their slopes are equal, we're going to say the lines are equal. I'm going to summarize this in sort of like an abstract way. I'm going to say L1. Whoops. Let's go back to ink. L1 is parallel to L2 with the understanding that this implies that M1 is equal to M2. All right. So here's the deal. L1 parallel to L2, it implies that M1 equals M2. All right. Again, there's a subtle exception to that. All right, I'm going to go to perpendicular. I'm going to look at the picture, but bottom line is I'm going to talk through the picture. After I talk to the picture, we'll come back to this over here, but we're trying to, understand what perpendicular means, at least visually. So what do they give me? They give me a visual, all right? And then they give me a test for that visual. Let me go to the visual, and, sure, I'm going to talk about it, right? One at a time, right? So it's a visual. I'm going to say this is line 1. I'll write that down for you. This is line 1, and line 2 is this over here. Whoops. And this is going to be line 2. Again, what am I going to do? I really want to draw a very simple triangle in to figure out what the slopes are. And I'm going to do the green line first. And this is a very simple triangle that I can count on. Again, this is rise. And this is run. Well, the rise appears to be 1, and the run appears to be 2. So line number 1, its slope, M1, is going to be 1 over 2. All right, let's do the other one. And let's take a look at that. I'm going to draw a simple. I'm going to use a checkered line this time. All right, so I'm looking at that checkered line. It's over here. Now this is going down now. So the rise appears to be -2 here. So the rise appears to be -2. Write that down for you. So this rise here appears to be -2. The run, I'm still moving to the right. The run is still 1. So let's write down the slope of the second line. And it's going to be rise, which is -2 over the run, which is 1. Now, what do you notice immediately about these guys over here? That there's a relationship, these lines. And I want to point out the relationship, at least what appears to be the case, that these lines appear to be perpendicular, right? They're intersecting at right angle. So I'm going to write this down as a summary. And again, what I'm appearing here, L1 is perpendicular to L2. Well, I'm looking at it, and certainly I want to discuss the relationship between the slopes. And what do I notice about these things over here? If I look at this guy's slope over here and this guy's slope over here, I notice that they're reciprocals of one another, like 1 over 2, 2 over 1. Not only reciprocals, but opposite in sign. So what I'm going to say over here that M1 times M2 would be equal to -1. Really, what am I saying? M1 is this over here, which I said the negative reciprocal. Put a box this over here. Again, we're depending on your intuition over here. And certainly, looking at that, let me just test it out. What's M1? It's 1/2. What's M2? -2 over 1. If you multiply it together, what do you get? -2 over 2, which is -1. Let me go back to the other page. And we're going to summarize that for you. So it's, if the lines are perpendicular, it's a big if, but let's go through this, make sure you know what I'm talking about. I did the parallel, right? Now I'm doing perpendicular. So, if the lines are perpendicular, I'm going to say the product of the slopes is -1. We typically write it this way over here. I'm also going to say negative reciprocal, right? Negative reciprocal. Then M1 is the opposite of 1 over M2. Or you might want to say M2 is the opposite of 1 over M1, the negative reciprocal. All right. So it's written right over here. Okay. As we go through examples, these two tests are going to be really important for you to understand. All right. These two tests over here. What are the two tests? And write the other one down for you. L1 parallel to L2 implies that M1 is identical to M2. Again, there's subtleties here that we haven't discussed yet, but we'll get to that when we're doing the problem set. What comes up next? Well, we're going to do the problems. What are we going to do? One after another. Hopefully you understand what we're doing, we'll build on what we know from the past, that is slopes of lines, and then we'll talk about what it means for lines to be parallel and perpendicular. All right, thank you.